Hello, anyone speaking? I can't hear anything.
Hello everyone. We are waiting for other participants to join. We'll start in few minutes.
Hello, good evening, everyone. Am I audible?
Yes, sir, you are audible.
Okay.
Sir,
Shubh,
we
when
will
we have to start?
sir, we will wait for 5 more minutes because the participants are still joining, and we'll start.
Okay, sure.
Yeah. Yes, thank you.
Hi guys, can you share the meeting details so that I can switch to my laptop?
Okay, I'll share in the chat box.
But
Hello, am I audible?
Yes.
So we'll start with the session. So hello and welcome everyone. I am Shubh Parmar, your host for today's webinar. My team and I are here to make sure you have a seamless and engaging experience. If you have any questions or need assistance, feel free to use the chat window. We are here to help. So the topic for today is developing LLM based application using Langchain. This is the Advantage India Skilling and AI NSI initiative by Microsoft aimed at empowering the future with AI skills at scale. It highlights key focus areas such as data and AI, Office 365 Copilot, GitHub Copilot, prompt engineering, and security. The initiative emphasizes the role of AI in skill development and digital transformation. Anyone who is interested to join these sessions, please connect with us. Anyone who wants to organize these exclusive sessions in your organization or college, please do let us know as these sessions are absolutely free. So today's event is sponsored by Synergetics. Synergetics is a leading edge learning solutions provider in India offering specialized training and consulting services. We empower businesses and professionals to thrive in today's fast evolving tech landscape by delivering transformative learning experiences. Our core focus is on enabling digital transformation through innovative skilling programs, advisory services, and end to end implementation support. From modernizing IT frameworks to mastering emerging technologies like AI, cloud computing, and DevOps, Synergetics is committed to equipping you with the tools and knowledge to succeed. These are the learning solutions which are offered by Synergetics, which are persona based onboarding, onboarding add on, certification add on, reskilling, emerging technology training, certification hackathon, cloud adoption, latest technology training, sales, pre sales training, practice playbook, and architecting. This is the Microsoft certification skilling journey. The journey begins with the fundamental certification, then progresses to advanced role based certifications, and finally to expert level certifications. We are thrilled to have Mr. Sonu Satyadas as our today's speaker. He is a certified Microsoft trainer and a consultant at Synergetics. He brings a wealth of knowledge and experience in AI and cloud technologies. The agenda for this webinar is overview of generative AI and large language models, introduction to Langchain features and capabilities, setting up the development environment, building basic LLM applications with Langchain, advanced concepts and application development, implementing memory in LLM applications, developing a custom chatbot with Langchain. You have to follow the code of conduct, which will create a respectful environment for all the participants. Participants, please note that you are not allowed to take screenshot of the presentation and cannot do screen recording. Do follow us on our social media platform to get relevant updates on upcoming webinars, workshops, certifications training we do. Also, the link is shared in the chat box to our social media platforms. We run communities on Meetup. This is the emerging technology community. Anyone who are eager to learn about technological knowledge can join this community on Meetup. We have multiple communities in Pune, Nagpur, Gujarat, and Indore. Those who are interested to join this community, please log in to Meetup app and gain your knowledge for free. Thank you so much, everyone, for listening to me. Now we'll hand over the mic to our speaker. Thank you so much.
Okay, thank you, Shuk. So, hello everyone. I hope I am audible to all of you. So, myself, Sonu Satyadas. I am the speaker for today's session. I hope the screen is visible to all of you.
Yes.
Okay, so In today's session, we will be discussing primarily about the Langchain, which is a framework for building generative AI applications. So this is an overview session because this is going to be a just 2 hour session to give you an insight about the Langchain framework. But yes, to know the details about the framework to build generative AI applications using the full capabilities of the framework, you need to get into the sessions. We will be organizing such sessions. Those who are interested can contact. And this session is just giving an overview about the features of Langchain. To start with, as I have mentioned, today we are using generative AI in our day-to-day life, in day-to-day applications, starting from the simple mobile applications to the enterprise applications. We are using the generative AI. Generative AI is typically used to generate the contents using the large language models like OpenAI, GPT models, Meta Llama models, Gemini model, Mistral. Like that, there are different large language models available. So you can build AI-enabled applications using this large language models, or you can also create the agents or tools which can later integrated into existing applications like co-pilots using this generative AI. But as a user, if you have to build a generative AI application which can be used as a virtual assistant, you can use frameworks like a Langchain or semantic kernel or some other. So Langchain is one of the most comprehensive toolkit used to build the generative AI applications. This framework helps us to build the generative AI based applications which can be later published as REST APIs or standalone applications which can be consumed from a customer application. Suppose if you want to create a chatbot which you can integrate with the existing applications, you can build the virtual assistance backend using this Langchain. But obviously, yes, front end of this chat UI interface you have to develop using some kind of front end application development tools, maybe Angular or React or some ASP.NET technologies, Blazor, etc. But behind the scene, it's using some kind of generative AI application, which may be generating the data using the pre-trained knowledge, or it will be using a custom knowledge, means a custom data source as a knowledge source. If you look at the Langchain framework, which is providing a set of libraries and tools for building the generative AI applications. Some of these tools are open source and some of the some of these tools are commercial. If you see, the core part of the Langchain framework is the Langchain libraries. These libraries are available for Python as well as JavaScript, which means if you want to create a Langchain application, you have to be a Python developer or JavaScript application developer, means Node.js developer. These libraries helps you to connect with the various services, including the databases, APIs, uh, the web services, etc. You can also see templates as part of this Langchain framework. So templates are used for creating the prompt structure, or if you want to create the prompt for executing a particular task, you need to define those prompt structure. So sometimes these prompts may contain dynamic variables. So you, for example, if I have to ask a question like, what is the temperature in a city name? For example, what is the temperature in Paris? But next time the user may be asking a different city name. So what is the temperature in New Delhi? Next time the city name will be different. So every time when the user is asking for the temperature, the city name is keep changing. So it's a dynamic value. So templates will help us to build the prompt with the dynamic values. And we also have some tools like a Langchain, which is a specialized library for converting these Langchains into the APIs, which is later can be deployed with the help of fast APIs. So fast API is one of the Python framework for building the REST APIs. So you can use the Langserve for building and hosting this Langchain frameworks or Langchain applications as a REST API using the fast API. Langsmith is a comprehensive developer platform designed for debugging, testing, and evaluating and monitoring the chains created by the LLM framework. So in Langchain, we will be creating chains. Chains are some interconnected set of tools for building the AI applications. In this demo, in this session, I'll be showing a couple of demos on how to create these chains. So if you want to debug, test, evaluate, and monitor this generative AI applications, then you have to use the LangSmith. LangGraph is an extension of LangChain for building the robust and stateful multi-actor applications with the LLMs by modeling steps as edges and nodes in a graph. So if you want to create a UI-based environment with a no-code, low-code solution, you using the low code and no code solutions. If you want to create the generative AI applications, then you can use the Lang graph. So these are the different tools and libraries available in Langchain framework. So to build a basic Langchain application, you need only the core library of Langchain. So as you grow, your application grows, you can also add more and more functionalities to that, like external integrations you can implement. Lang graph you can use for building the generative AI applications instead of writing a lots of code. The generative AI application development primarily goes in three stages. First is development, where we will be streamlining the prototyping, means we create the applications which may be a context aware system. That means it may remember the context data uh, over this configuration or over this conversation. Suppose if we are talking about a particular topic, that topic's informations can be stored in the conversation history to maintain the conversation context. Apart of that, if you want to provide some custom data, that also can be provided as part of the context data. Integration support. So during this development, you can use the tools for integrating various services. For example, if you want to connect to external APIs, external databases, they provide some built-in tools or built-in functionalities for connecting to this external services. Product readiness provides resources for debugging, testing, evaluating, and monitoring these applications like a Langsmith, which helps us to do all these monitoring activities for our AI applications. Collaborative development. It encourages and supports collaborative efforts in the developer community. So you can build the applications in a collaborative environment. So after that development, we will turn this into a product where you will be configuring the scalability. You will be testing the product or service for robustness. You will be integrating the monitoring tools, and we can deploy this application. So sometimes we'll be configuring the CI/CD pipelines for deploying such applications. So for deploying, typically we will be using the Langserve, which is an API for converting your Langchain into a REST API. So you can integrate this with the Fast API, because Fast API is one of the lightweight framework for building the REST APIs. If you look into the common components of Langchain, primarily there is a model. A model can be from any vendor. Suppose if you are interested, you can use the OpenAI models, or you can use the uh, other Hugging Face models or Llama models or the Google's models. So there are different large language models available. You can use these large language models to generate the response. For that, you will be writing the prompt. Either you can write a simple text prompt, or you can use the prompt templates available in the Langchain. So prompt template is just defining the structure of the prompt. Suppose if it contains the dynamic values, that dynamic value can also be integrated within the prompt. Then another major component or another major phase is the retrieval, where you will be using multiple tools like document loaders. For example, if you are creating a retrieval augmented generation application, which is RAG application, your application needs to get the data or custom data from some external sources. It may be a PDF file, or it may be a web URL, or it may be something else. So you have to fetch this data from those external sources. We can use the document loaders for that. Then we will be using text splitters and embedding models. So text splitters are typically used to split the larger text data into small chunks. And the embedding models are used to convert this text data into the uh, numeric format, because if you have to implement a RAG based approach, we need to store the data in the form of numerics, that is vector. So for converting the text data into the vector, we can use the embeddings models. Then we will be also using vector store for storing the vectorized data. Suppose if you have to convert the given text into the vector format or numeric format, you can use a vector store to store that data. It can be any kind of database. It may be a NoSQL database or SQL database. Retrievers are some generic interfaces that allow us to fetch the data from the database. Suppose if you are performing a similarity search query, when a simple search query, it is going to use this retrievers to get the data from the backend data source, means the vector store. Then we also have composition of tools, agents, and multiple chains. Means it is possible for us to execute multiple functions, a user-defined operations within a Langchain application. So you can create Python functions or JavaScript functions as tools and integrate within the Langchain application. Agents construct that choose which tool to use given high level directive. So deciding, agents are used to decide which function to execute. Maybe one generative AI application or a chatbot may be capable for executing multiple operations, maybe checking the weather from the backend API, or storing and retrieving the data from the database. Or it may be any kind of external service references. So you can write these operations as functions or tools, and these tools can be executed using the agents. Maybe they will be using a single agent or multiple agents, and each agent may be using one or more tools. And chains are typically the output generated as part of this Langchain application, because ultimately we will be creating a chain which can be uh, created by integrating various components like the retrievers, text splitters, embeddings models, vector stores, and retrievers. So by combining these tools, we can create a chain. And additionally, we can also integrate memory for persisting the context data. Suppose if it is a long conversation, maybe we cannot fit all the data in the memory. So sometimes we have to persist the data in the disk or some other database. Callbacks like logs and stream intermediate steps of any chain. So when you um, call these APIs using APIs as streams, it is going to print the result as the data is produced. For example, typically what happened is whenever you make a request, the chain will execute. Once the chain execution is finished, only the final result will be printed on the screen. But nowadays, the applications can use a streaming capability, which is going to display the results as they generated. For example, if I make a request, means by raising a prompt, it will generate sentence by sentence or word by word. Suppose if it is generating the first word, that will be printed on the screen. When the second word is generated, then it is going to print the second word like that. So such operations we do using callbacks. Let's first understand what is model. As I have mentioned, we can use large language models for performing the AI operations. You can ask almost any kind of question to these large language models, and these large language models will be understanding the structure of your request, understand the prompt, and then execute that request. Primarily, there are two type of models we use. Either it can be a simple LLM model or it can be a chat model. Simple LLM models are also called the completions models, like a GPT 3.5 Turbo Instruct is an example for simple answer generation. But if you have to interact with the virtual assistants, then you need a special type of model called a chat model, because as the name indicates, it is used to uh, generate or to create a conversational AI application where the user can converse with the AI models. As you see here, the first step of this model execution is formatting the prompt. So what you need to execute, so you can create a prompt for that. Some of the prompt may be containing the variables, dynamic values. So you can integrate the variables and the prompt and then send this to LLM models or chat models. LLM models here means it's a simple generic uh, large language models. Once this large language models generate the result, it will be then sent to the output parser. So if the data is coming in a JSON format, it's going to print that JSON response, which is coming from the application or from the AI to the screen. So it can be a JSON data, or it can be some plain text data, or it can be something else. Let me show you an example how to configure these models in Langchain. Let me reshare. Okay, I hope the screen is visible. Sorry, somebody is unmuted. Please mute yourself. Okay. Okay, so first of all, we have to set up the development environment. So basically, we need a Python environment. For that, you can switch to a folder and then create a Python virtual environment. So this, I have already created a virtual environment inside this. Okay. So this is the virtual environment I have. And I'm going to show the demo in a Python notebook. So instead of writing the Python script, I'm going to write it as a notebook file. So let's name it as app1.ipynb. So I Python notebook means interactive Python notebooks. So here you can see it creates a Python notebook, or you can, if you want, you can also use the Python file, py file, but I'm just doing this in a Python notebook. First thing, after creating this file, you have to select the kernel. From here, in my case, it is supporting two different environments, .NET and Python. So I'm selecting the Python. And this is the one which is there in the virtual environment, 3.10. So very simple example. I'm just printing a simple message to verify whether it is executing or not. Yes, you can see it's just executing this hello world example. Means it's a working file. Okay, this can have the files. So next thing is we have to have the libraries installed. So inside our package or inside our virtual environment, we need to install the Langchain libraries required for building the application. So for that, I'll just remove this test code. We can execute some Python command, pip command using this. Pip install, and then I can use Langchain. And also I can install OpenAI. Execute this. So it's installing the library. It may take a minute to install that. taking time. Okay, by the time. Let me take. Okay, so you can see it is now installed. I'm just clearing this output. After that, we need to import the OpenAI. So for that, I can use this package which is there, which is installed. So I can use from Langchain. It's not installed Langchain OpenAI. So I think this not only the OpenAI, Langchain OpenAI also will install. It's installed. So this is not found. Here, let me take the library, Langchain. This is the package. Okay, so this is the package name, Langchain-OpenAI. So I have installed the core library, which is the Langchain, and this is the Langchain OpenAI library. And once this OpenAI, Langchain OpenAI library is installed, we can import this OpenAI from this Langchain OpenAI and then create an object of this OpenAI, that is the LLM. And inside this, you need to pass the credentials for the authentication. Suppose if you are connecting to the open AI, you need to specify the key for that. Suppose since I am using the OpenAI model, you need to specify the API key, and you can specify what is the API key uh, available. So suppose in my case, I have a test key generated. So I'll be directly copy pasting. So this is the key. So you can see it's creating an LLM object. LLM is simply means the large language model, which represents the open AI. And then we can execute some prompt, or we can invoke some prompt. For that, I can say result equal to, or maybe response equal to LLM dot invoke, and then you can specify the prompt. For example, if you are asking about how far is moon from Earth, so this is the question I'm asking. So if the LLM is properly configured and it is authenticated, it is able to generate a response for this question, and it will be printed here. So you can see it is returning a response. The average distance from Earth to Moon is so and so. So this is what the response coming from the LLM. So here, the model which I have configured, or the LLM model which I have configured, is the Open AI. So you can specify which Open AI model specifically you are using. So this is using the default Open AI model. Okay, inside this application, I'm creating an instance of this large language model and invoking a simple prompt. So I am just making a request to uh, generate a text response. But it is also possible for us to use the chat open AI, which is a chat model. So this is the completion model. So if you are planning to use a chat conversation application, instead of this open AI, which is a normal LLM model, we can also use the chat open AI model. So in the chat open AI model, I'll just show you how it is. So you have to import it from Langchain OpenAI, import chat OpenAI. So chat OpenAI is typically using the chat models like the GPT models, GPT-4, GPT 4.1 kind of models as a backend large language model. So this is the new models that we use, because most of the new models that we use is using the chat open AI library. And you can create an LLM for this chat open AI. Also, you can specify the API key and then make a request response equal to LLM dot invoke, and then I can ask which is the so I'm just asking which is the largest mountain in the world, and you can see it's going to generate the response. But compared to the previous response, we can see it is simply returning the plain text as the response because I was using the OpenAI library or OpenAI API. But when you use the chat OpenAI, it is returning a document object which contains a content. Okay, so you will see it provides some additional information. So this is what the additional information which is coming from the response. So we can see it is used this model to complete the execution. And it also shows how much tokens it uses. This is the input token and this is the output token. So total tokens consumed is 59. Okay. So this is what the difference. So this is the response which is coming from the chat OpenAI, and this is the pure text which is returned from the OpenAI model. So you are able to specify which model to use. I think model name, we can say GPT 4.1. I think. If I'm not wrong, that is the correct name of this model. So this is used. Here you can, so you can see here, this time it was using the model which is specified by the user. So you can see instead of using a default model, this time it used a model which is specified by the user. So GPT 4.1 I have explicitly specified. So it is using that model for completing this execution. So otherwise, if I'm not specifying this, the API will use a default model. I think by default it is GPT 3.5 turbo model. So you can see in this documentation. Yeah, default is GPT 3.5 turbo model. So this is what the models case, which I have told. So when you build the large language, when you build the chains or Langchain applications, the first step is to create or to select a model according to your requirement. So you can either use an open AI model, which is not a chat model, which provides only, or which is also called as a completion model, which is going to generate the simple text data. But chat models are always generating a chat response from the assistant. Okay. So GPT 4.1 or GPT 4.0, these are some examples of the chat models. So this is what the difference I have just showed, chat models and the LLMs. So LLMs are simply completion models, which is just creating the text data. But chat models are typically using the uh, chat model message structure for generating the response. Prompt templates. So prompt templates are used to define the structure of your prompt. So most of these LLM applications, the user is not going to provide the prompt directly. They may be providing the parameters or variables only, but the prompt need to be constructed. Okay, for example, so if I have to execute some operations from a front-end applications, instead of the user is writing a prompt, user must be selecting a value from a drop-down list. So when the user select a value from the drop-down list, we have to go and filter out the values or fetch the informations based on the selected value. So we will be writing the prompt in the prior, but the value of that drop down will be inserted into the prompt dynamically. So for that, we need to use the prompt templates. So if you look into this, we need to use the prompt templates from the Langchain core package. Okay, Langchain core.prompts, and we can create the prompts from the template. So what is the template here? What is a good name for a company that makes some product name? So if it is biscuit, then it makes it the question or the prompt will be like what is a good name for a company that makes a biscuit? Suppose if the product name which I want to use is maybe cool drinks, then I can say, what is the good name for a company that makes cool drinks? So look at that. As a user, he will be providing only the uh, uh, product name as a dynamic value, but the prompt will be generated by the user using the prompted template structure. Okay, so 1 minute. Screen is not shared. Is the screen visible now? So if you look at this, we have to use the prompt template from the Langchain core package, and we need to define the structure of your prompt, including the variables. Maybe one or more variables we can use, and using that dynamic variable values, we will define the prompt. Okay, so what is the value we are providing for structuring this prompt? It generates a text prompt by integrating or by rendering that variable inside the prompt. For example, here you can see what is a good name for a company that makes a product. So here product is a dynamic variable, and here we will be passing from prompt dot format, and then we are passing the variable name and the value. So it creates a prompt like this. And chat prompt template is typically used to define or to use with the chat models. So previous section we have discussed there are two type of large language models or two type of models. One is the completion models, which is simple text models, and another one is the conversational models, that is the chat models. In chat models, whenever you define the prompt, you need to define the prompt in the form of a conversational message, where each message will have a role and a content. Role means it can be a system or user or assistant. Okay. So that means it can be a human message or system message or AI message or assistant message. So if you look into this, this is a simple chat prompt structure creation. So we are creating a chat prompt from messages. So from a list of messages, we are creating the chat prompt. In this case, you can see the first message, what we are passing is a system message. So what is a system message? Which is typically used to set to the persona of the assistant, or it can also be used to define the do's and don'ts of this model or the assistant. So what the assistant has to do, what it should not do, so that you can define using the system message. And human message is typically used to what to say define what is the user prompt. Okay. So when we format the messages, we need to pass the variable values which is used inside the uh, prompt. So if you look into this, there are three variables. Look at that system template. What is a system template message? You are a helpful assistant that translate this language text to this language. So there is an input language variable and an output language variable. And then there is a human text or human message, that is what is the value that is passed as a variable here. Text is the variable. So when you define the chat prompt, you can use this template, and while formatting these messages, you can replace these variables with the actual values. So this format messages function is actually going to return the formatted messages, means variables will be replaced with the values. So let me show you an example of that. So I hope the VS Code is visible. So we have already created the LLM. So this is the LLM. And now what I can do is I can create one chat prompt. So from Langchain core dot prompt import chat prompt template. So we can import the chat prompt template, and then we can create the prompt template or prompt structure. So chat prompt equal to chat prompt template dot from messages, and then you can define the system message and the user message. So in the system message, I can say you are a helpful assistant to translate text from some language, that is input language, to your output language. And here is the user question or user text, whatever it is. So if you look at this, I am creating a prompt template. So this is the prompt template I'm creating from messages. So chat prompt template, I can say. So this is a prompt template, that is this one. Then I can format this template to create the actual message. So chat prompt template dot format messages, and then you will be able to specify the values for this variables, like input language equal to English or French or whatever it is, and output language, which is the second variable which is used here, that is French, or maybe something else you can specify. And there is a third variable called a text. So that text variable value is the user input value. So whatever is the text he wants to convert. For example, hello everyone, welcome to the world of Langchain. So I'm just giving this, and it's going to create the prompt. So if you look at, or if you print this prompt, you will be able to see there is a system message which is saying you are a helpful assistant to translate the text from English to French. And there is a human message which is hello everyone. So this simple variable is now replaced with a text that is hello everyone, welcome to the world of Langchain. So this prompt is now rendered and it is created the response. So let me try to invoke this. You can see when I invoke this, it is generating an AI message. See, I have specified system message, which is a general instruction to the model. So what is the instruction to the model? You are a helpful assistant to translate the text from English to French. Next, human message is or user message is, hello everyone, welcome to the world of Langchain. So when the model responds, means I'm executing the prompt. So the prompt is executed by the LLM and the LLM returns an AI message. The AI message content is, you can see here, this is the French equivalent to our text. Suppose if I'm changing my language to maybe Hindi, run this. You can see this is what the Hindi translation of the given text, right? So here, this is the chat uh, language or chat model. And the chat model, we are using the messages chat prompt template because every information is passed as a message. Suppose if you want, you can also provide some contextual informations using the conversation history. That means in the form of examples. So let me give an example for that. Suppose if I am giving chat prompt template equal to chat prompt template dot from messages. So here I'm just saying you are a helpful assistant to analyze the sentiment of the given user or given feedback. And here I can provide the feedback. Okay. So what I need is it is supposed to provide the feedback of the user text. So let me create the prompt templates and then I'm creating the prompt from that. So prompt equal to chat prompt template, that is this variable dot format messages, and then I can specify the variables. What are the variable value? There is only one variable. Okay, that is a feedback. So feedback, what is a feedback? User feedback equal to. So I'm just giving a positive feedbacks. What is this positive feedback? The product is really good and I'm very happy with it. So this is the prompt. And when I execute this with the LLM, it is creating the response. So if you look at this, it's analyzing that sentiment is positive. Okay. And it is giving the explanation of that also. You can see it is giving a response like a sentiment equal to positive. And what is the explanation? Why it is considered as a positive. Suppose if you are giving a negative feedback, for example, I don't like the quality of the product. And if I execute this, we can say it's give the sentiment as negative. But as a user, if I am if I'm expecting the response in a different format, means typically it is giving the response in this format, sentiment equal to negative or sentiment equal to positive or sentiment equal to neutral. But instead of that, I want the response or I want the feedback sentiment value to come as a number. For example, if it is a positive value or if it is a positive feedback, it has to return 1. And if it is a negative feedback, it has to return -1. And if it is a neutral feedback, it has to return 0. So that is the expected value. Means instead of giving the positive, negative, and what to say, neutral, I want this to be a numeric value. So for that, in my chat prompt template, instead of giving the feedback directly, I can provide some examples. So here, I can give the first example. That is, so I'll be providing a feedback like the product is amazing and I love it. So I don't want the value to come as positive. Instead of that, I want the result to come as 1. Okay. Now, second example I can provide. So here the product is okay, but it could be better. So it's a negative, sorry, it's a neutral feedback. So it's a 0. I can give a third example, which is I don't like the product at all. And this is returning -1. It's a negative feedback. And then I can say the user feedback or user input. So this is the actual user input, but I'm including some examples here. So why I'm including these examples? By looking into these examples, my model is able to understand, okay, instead of giving the response like this, I'm supposed to give the answer in a numeric format. So let's try this, run this. So this is a negative feedback I'm providing, and let's see what the result comes. You can see instead of giving the response in a text format, it is now giving -1, that is -1, which is the expected value. Suppose if I give a positive feedback, like I like the quality of the product, and when I execute this, you can see it is giving 1. So this example helps the AI model to understand how to generate the response. This is actually the few short learning example. Okay. So inside the chat prompt templates, we can include this conversation history. So this is the conversation history, but I'm using the conversation history for examples. So this is a conversation. So this is the first conversation. There's a second conversation, there's a third conversation, and this is the last question. Okay, so the conversation history is attached before we ask a question. The next is output parser. So output parser is typically used to format your responses. So that means whenever the LLM generates a response, you can see the response is coming in an object format as a AI message format. But in my applications, I don't want to go and process that object result. Instead of that, I may be expecting the result in a particular format. It may be a comma separated value format, or it may be a simple string format, or it may be some other format. So what is the expected response? So you can tell the model to, or you can tell the app Langchain to convert the generated result into that particular format. So for different output formats, there are different formatters available. For example, I'm going to create a small chain here. So I have this prompt. This is my prompt. Okay, let me uh, remove this one. So let me take a different example. From Langchain OpenAI, I'm using Chat OpenAI. From Langchain Core dot prompts, I'm using the chat prompter template. From Langchain Core dot output parsers, I'm using import str output parser. So you can see I have three inputs. One is for the model, one is for the prompt, and one is for the output parser. Now I'm going to create the LLM first. So LLM is already defined there. I'm just copy pasting this. This is the LLM. Then prompt template. Prompt template, I'll use the same. This one. Okay. And we have to convert this into a prompt. So this is what the prompt generation. So here input language is English. The output language is Hindi, and this is the user input text. Okay, so if you want, you can use input. So this is an input from the user. So I'm just executing this. Okay, the prompt template is created. Then the prompt here it is asking for the text. For example, hello, how are you? This is the text that I have to use. So now I have the LLM, I have the prompt, and I'm going to create an output parser also. So parser equal to str output parser. So which means I am creating a string output parser. So parser is also created. Now I'm going to create a chain. Chain equal to, so my prompt, sorry, chat prompted template, LLM, and the this is my chat prompted template, LLM, and the parser. So chain dot invoke, and then I can provide the parameters. What are the different parameters? So this is what the parameters which I'm using. Okay, I'm just tested with this parameter. So I can use the same 3 parameters while invoking this. Okay. So when I invoke this, I'll get a response. I'm printing the response here. So this is the text I'm inserting. What is that? Or this input is missing. Because when we use chains, it has to use some specific variables. So for this, I can do. Some extra variables, output language and input language. If there is a dictionary, we can pass. Because when we execute this as a chain, we are supposed to pass it as a dictionary. Or somewhere it is mentioned text. Which is not executed again. Missing variable text. Where it is mentioned text. This is not the text. LLM. This is fine. This is fine. We provided direct text. Okay. Okay, so here you can see, yeah, there was some problem with the variables. So if you look at this, there are three things I have used, which is combined. And this is the first one, which is the model. So when you create a chain, the first thing is the model. So we have a model, which is a open AI model used. Second is the prompt or prompt template. Prompt. This is the prompt template, which is automatically rendered using the input parameters passed here. While invoking this chain, we will be passing some parameters. So it will automatically render this prompt with the appropriate parameters. So if there are three variables or three parameters required, so we are creating the prompt. And the third one is the output parser. So this is the output parser. So output parser is typically used to uh, convert your text into an appropriate format. So since this is a string output parser, its a responsibility is to convert the text or convert the result object into a plain text format. So if you look at this previous examples, whenever we execute the LLM, the result is actually coming in which format? This AI message format. So this is an object, AI message object format, and it has these many arguments. There is a additional KW arguments, response metadata object, so and so. So it's like an object. So I don't need this object, okay, from the response, that is from the AI message, which is used here also, you can see. From the AI message, I need the content. Content is the actual output text. So I need the actual output text and I don't need the complete object. So how to extract only that output content from the AI message? For that, we can use the string output parser. So there are the other output parsers available, like a JSON parser, XML parser. There are different parsers. So depends on which format you want the output. You can use the parser. So there's a string output parser which returns the data in a string format. So now I'm combining these three, model, prompt, and output parser, to create a chain. So this is the chain creation where I'm creating the prompt, that is the chat prompt, then pipe symbol, which means I'm passing the output of the prompt to the LLM. So the chat prompt is rendering the response, or sorry, rendering the template with the variables and create a prompt. That prompt is passed to the LLM, and LLM will execute it, and that LLM's execution result is passed to the parser, and parser's responsibility is to print the text message or return the text message from that response. So we are creating a chain that is connecting multiple things. There is a prompt, then model, LLM model, and an output parser, right? And whenever we invoke the chain, we are supposed to pass all the parameters of that prompt. So here we need a output language, input language, and the text. When I invoke this, we can see it is returns the result. So here you can provide any dynamic value like an input, or you can accept an input value and put that value here. So for example, user input equal to input of enter the value or enter the text to be translated, and this can be replaced with the user input. Now if I run this, you can see it is asking, so I am teaching Langchain. This is my text, and you can see this is the translated text. So whenever I run this, it is accepting the user input and then generating the response. So this is a very simple chain. So this is the lang chain because we are chaining the prompt, language, and the parser. So this is the Langchain expression language where you can combine prompts, models, and output parsers into one chain. And we will use this pipe symbol to join these components here. So we have already discussed about that. Now, another important concept is retrieval because retrieval is important because in most of the organizations, when they use generative AI, they don't want to use the pre-trained knowledge to generate the answers because nobody is going to ask a question like how far is moon or who is the first president of USA. So these questions you can even ask in ChatGPT also, right? But we want the model to generate some answers based on some custom data, which was not part of the model's training data set. Because the LLM models are trained with the internet data, but if I want to use this model to generate the answers based on our organization specific data, such cases, we have to use the retrieval augmented generation approach. So what is this retrieval augmented generation? It is a way of customizing the large language models. Because typically large language models uses a pre-trained knowledge to generate the answers. But what we want to do is we want the LLM to generate the answers based on our custom data. Custom data means, for example, if an organization wants to create a virtual assistant or a chat bot for answering the employees' questions about the company policies. For example, if I ask a question like, what is the reimbursement policy if I travel outside? So, because employee don't have time to go and read the complete policy, so he go to the chatbot and asking a question. So, as per the company policy, what is the reimbursement policy if I travel outside? So company may be ABC company. So ABC company will have a travel policy or employees policy, which talks about salary policy, reimbursement policy, or maybe incentives, other details. A lot of policy details are there. So we want the model to generate the answers based on that policy which is only available inside the organization. It's not an internet data, right? For example, if you are working in a company called ABC, do you think the ABC company's policies will be available in internet? No. So no companies will be publishing their employee policies publicly on internet, right? So it's a proprietary data for that organization. But we want our large language model to generate the answers based on that custom data. So for that, first we have to convert those custom data into embeddings and then store into a vector database. Then only the model is able to generate the answers based on that. So for that, you can see there's a pre-processing step. What is this pre-processing step? We take the document. So this may be a PDF document or this document may be available in internet. Internet means in the company website, which is not public. Okay. So we can assume that it's a PDF document, which is describing the company policies. So these are company's policies PDF documents. We convert that into embeddings, means numeric format, using this embeddings model, and then store that converted embeddings data, that is numeric data, into the vector database. Okay. This vector data is used as a knowledge source, which means whenever the user is asking a query, so here you can see the user is asking a query. Before the LLM is generating the answer, what it does is the query is first converted into embeddings using the embeddings model. You can see the query, that is a user question, is converted into embeddings, means numeric format, and then it will do a search inside the database. So it will do a search inside the database. That process is called a retrieval. Okay, because it performs a semantic search or similarity search to find the matching information. For example, if the employee is asking about the traveling policy, so this question is first converted into numeric format and search inside the database for the similar data. So inside the database, there is lots of policies, but we are searching for which policy? Travel reimbursement policy. So it will find out similar data, not exact matching data, finding the similar data. There may be multiple documents or multiple pages which may contain similar policy informations. So it returns more than one matching results. And those matching results will be sent to the LLM model along with the query. You can see query plus context. Context means the search result. So the query and the context is sent to the LLM, and the LLM is generating the response. So retrieval and augmentation and a generation. So because of this three stages, it's called a RAG, retrieval augmented generation. So retrieval means searching from the database and find the matching results. Passing the query and the matching results to the LLM is the augmentation process, and generating the results based on the context data is the generation phase. That's why it's called a retrieval augmented generation. So for that, first step is to take the data from various sources, maybe from web pages or from the documents. We load the data. Load the data means data will be very lengthy. So we have to split that data into multiple chunks. So in the transform stage, you can see we are chunking those data. So larger data is split into multiple pieces, and each one of this piece is converted into an embeddings model. So you can convert that into numeric format, and then we store that data into the database. So store is the vector store. It's a database. It can be MongoDB, Milvus, Pinecone, Redis, and many other storage services there. And that database is later used for the retrieval purpose. So Langchain is providing different document loaders for reading the data from various data sources. For example, if you want to load the data from PDF, we can use the PyPDF loader. If you want to read the data from website, we can use the web-based loader. If you want to read the data from CSV, we have CSV loader and so on. So there are different types of loaders we have. So from where the data needs to be loaded, so we can use the appropriate loader for that. Splitter is used to split a large document into multiple small chunks. So if you look into this picture, you can see this large document is splitted into multiple small chunks. That for that we can use the text splitters. So recursive characters text splitter is an example for that. So it will split the larger text into multiple small pieces, and each piece may be of 1024 or some other size. So maybe you can put 1000 tokens per chunk. Yeah, so in one piece, there may be 1000 tokens. Like that, you can split it. Once the splitting is done, then you will be storing this data inside your database. So splitting can be done either length based, means you can specify what should be the length of this uh, chunk. So we will be splitting the document based on the length, or text structure. Text structure means suppose each paragraph will be converted into a chunk. So one paragraph is one chunk. Second paragraph is a second chunk. Third paragraph is a third chunk. Whether it is a big or small doesn't matter. So each paragraph can be converted into separate chunk. Okay. So that is another approach. So sometimes we use length based one. Sometimes we use the text structure based. Third one is the document structure based, like they if they are HTML, Markdown, or JSON, based on the document structure, like nested objects, like a hierarchical objects, we can store them in the we can extract them in that particular format and then convert. And we use embedding models to convert this text into the numeric format. So embedding model, typically we will be using the text embeddings ADA002 or text embeddings 3 large or text embeddings 3 small if you are using the OpenAI models. But if you are using some other providers, then accordingly the model name will be different. But mostly if you are using the OpenAI, we will be using the text embeddings ADA as the embeddings model. So here is an example. We can create the embeddings model object, and what is the model name we are using, we can specify that, and then we can convert that text into the numeric format. For example, here embeddings model dot embed query means we will be converting this text into numeric format. So let me show you an example of that. So in this, so we can use the embeddings model from Langchain OpenAI, import OpenAI embeddings, and then create an object of that embeddings equal to OpenAI embeddings, and then you can specify the API key. And if you want, you can explicitly specify a model name also. So I'm using the text embeddings ADA002. Then using this embeddings model, I'm going to convert a text into the numeric format. The embed query I can use to convert. For example, hello, how are you? So this is the response which I can print. You can see this is the response which is generated, and I'm printing this response. So typically, because I have used this model, the length of this response, you can see it's an array of numeric values. So these are the dimensions. So you can say dimension means it's like an XYZ dimension. So how many dimensions will be there? You can find out. Depends on the model, the number of dimensions will be different. So for example, typically in a two-dimensional vector, there is an X dimension and a Y dimension. In a three-dimensional vector, there will be three values like a X comma Y comma Z. In a four-dimensional vector, there will be X, Y, Z, and K, right? So we can specify, or we can say that how many dimensions are used in this vectorization process. Okay, because your data will be placed in a vector dimension, and the vector dimension value will be returned. This is what the value. But how many values or how many dimensions will be there, that you can print using this len. So len of response 1536 dimensions will be there. So when you use text embeddings ADA002, the number of dimensions will be 1536. But if your text embeddings 3 large, it will be more than that. 3000 something. 3072. Okay. So depends on the model, the number of dimensions will be different. Okay. So this is what the dimension generated. Now, if I have to uh, convert one document into a vector format, then what I can do is I can use a loader. Loader is typically used for loading the data from a particular data source. It may be a file, or it may be a web URL or something like that. So I'm going to use the web-based loader. So web-based loader, if you have to use, you have to install a particular library called the Beautiful Soup. So this is the library which is required. I'm installing that. Okay, it's done. From Langchain to document. Or it's a community or the form. So because it's Langchain dot yes, let's see. So here is the loaders. Suppose if you are using the web-based loader. Yeah, beautiful. Okay. This is also required. Okay, so we have to install two things. One is Beautiful Soup for and a Langchain community. So that was missing because the open source community driven packages are coming from the Langchain community. Since it is a document loader, for that you have to install this, and it is a part of Langchain community, so it has to be installed. It's taking a lot of time to install. Okay, it's done. Now I can import this. Okay, it's done. Web-based loader is imported. Now we can create a loader object. Loader equal to web-based loader. And then you can specify the URL or that the path. So you can specify what is the path we want to use. So you can give any URL. Maybe I can take wiki. This is one movies Wikipedia page. So I'm just taking this URL. So I want to use this as the data source. So my questions to be answered based on this. So that's why I'm loading the data from this. So I'm creating a loader. Then I can first uh, create the documents using this uh, loader, right? Load and split I can use to create the documents. So documents equal to loader dot load. If you are using, it is just creating a single document with all the text content. But if I want to explicitly convert that into small chunks, then you have to use a recursive text splitter. But if I call this load and split, it will internally split that into multiple documents. So that means here you can see it returns multiple documents. So in the PPT, you must have seen a large document can be converted into or splitted into multiple small documents by using the load and split. So loader dot load and split will be converting this into multiple documents. And these each document we can convert into vector format. Okay, so we already have the embeddings model. So we can use embeddings dot embed documents and we can pass the documents here. Vector data equal to, so this one. So each one of this document will be converted into vector format by using this one. So we'll be passing this as a list. We have to provide the text only because documents will be containing. I think it is content. Okay, let me just print the first value. Metadata and the title. Okay, page content. So here, then it should be document dot page content. So this is the vector data which is created. If you look at this, from this documents, each document's page content, that is the text data, I'm converting into vector data format and stored here. So this is what the document. So if you look at this, here we are converting each one of this document into vector format. So I can explicitly convert the documents, the chunks into the embeddings by using the embed documents, and each one of these document can be converted into vector format. But if I have to store this into some vector storage and perform some kind of maybe similarity search, something like that, then you have to install the appropriate storage library like Facebook Artificial Intelligence Similarity Search, that is FIAS. And also you can simply convert that documents into vector format and store inside this uh, vector data or vector storage. So here, this is the explicit conversion of this documents into the vector data. But if I don't need to do that explicitly, what I do is I will install one more library explicitly. Okay, so let me install one more library. Pip install this FIAS CPU. So this FIAS is actually a vector database, which is used to store the vectorized data. And I can use this to store the vectorized data and then perform a similarity search. So here I am importing the web-based loader, loading these documents from this URL, and then I can use uh, from okay, so we have to use the stores. So this is the FIAS import, which is a vector store. It's an in-memory vector store, you can say, and I can use FIAS to FIAS from documents, and you can specify the documents name, like documents equal to the documents list. I can specify that is here is the documents which is loaded from the web page. This is from this URL. So we have converted that into small chunks and stored into documents. And then for converting each on one of this document into the embeddings format or vector format, we need the embeddings model. So embedding equal to embeddings. Embeddings is the embeddings model which we have created. So this is going to convert each one of this vector data into the embeddings and store into the vector store. That is the memory for our application. So this is going to store the vector data of this documents. Now I can start doing the similarity search and find the matching document. For example, I can say vector store dot similarity search, and I can ask a question. For example, who who is the director of this movie? Okay, so this is the results equal to. So here I can say k equal to 1 or k equal to 2 or k equal to 3, whatever you want. How many top matching results has to come? So that number of results you will get it here. So it is performing a similarity search. Okay, so I'm asking a question. So it will go and do a search based on the data which is stored inside the vector store and the result. Let's see how many results are returned. Results. So you can see here, this is one matching result. The page content equal to, this is the one. So how many results if you want, you can say length of results. So it shows how many matching results returned. You can see, yes, 3 matching results returned. So you can see here, we have extracted the text information from the web URL and storing them into a vector store. So FIAS is the vector database, and I'm converting these documents in using this embeddings model and store into the vector store, and I can perform a similarity search. But now, if I have to actually perform the RAG application, so manually searching and finding the information will not give you the final result. So what you need to do is you have to create a chain that is going to provide the uh, results. So for that, you should create a prompt, you should create the LLM, and you should create a output parser. So we already have the output parser and the LLM, but prompt we have to recreate, because in this case, I can say prompt equal to chat prompt template from template, and I can define the template like this. So you can see here, I'm creating a prompt like this. You are a helpful assistant to answer the question based on the context provided. And here is the context, and here is the user question. So context means the search results, what we are passing. So the search result is going to come as the context, and I am asking a question. So this question will be answered based on this context. So this is my prompt. Okay. So now I have to create a chain for doing this operation. So I can say chain equal to I have the vector store which is containing the data. So I can say vector store dot as retriever, and then we will be passing this to the prompt. Okay. Context data need to be specified. So this context data is coming from the vector store, comma, the question, that is the user question, is coming from the user input, which is a runnable pass-through. So that we have to explicitly import. Maybe I can import it here. Runnable pass-through. So then this has to go. This has to go to the prompt, and then the result of this prompt has to go to the LLM, and then it has to go to the output parser. So that means we have this uh, chain, but the chain is created using this what to say uh, vector store, and the vector store as a retriever, which means the context data will be coming from the vector store, and the question is coming from the user input, that is a runnable pass through, and then the prompt is the one which is going to uh, uh, render this context and the question. So because this is the prompt which is going to be executed by the LLM. So we have to replace this context with this, and the question to be replaced with the user input. And that two variables will be rendered inside this prompt, and then that will be passed to the LLM, and LLM's response will be then passed to the output parser. So this is how the chain is created. So in RAG approach, we will be adding this explicitly because our context data has to come from the vector store, and the question has to come from the user input, and that variable values will be passed to the prompt. The prompt will be rendered, and then the rendered prompt is going to the LLM, and the LLM is going to generate the response, and the generated response is parsed using the string output parser. Now I can invoke this chain just like a normal chain, like LLM dot invoke. So I can ask the question which I have asked for the similarity search. This is the question I'm going to ask. You can see it is giving the result like a content is equal to, could you please specify, sorry, this is not taking this vector store. Okay, let me rerun this completely. I think all I have to rerun. LLM, parser, then embeddings, okay, loader, document generation, storing into fires and vector store. And this is the prompt. And here is vector store as a retriever and question as a runnable pass through. But it's giving So taking the store. It is correct only. Context. Search result is getting is it because of the variable name that's already used? Oh, sorry, LLM I have used. So chain dot invoke. Sorry, I have used the wrong variable. So chain I have to use. Okay, so chain is created, and using the chain we are invoking. I think I have used the LLM to invoke this. Okay, so you can see here the answer is coming. This is the answer which is parsed by the output parser, right? So now if I'm changing my question, for example, what is the budget of the movie? Suppose if I'm asking this question, the budget of this movie is so and so, right? And I can ask another question, who all are the lead actors in this movie? So you can see the actors' names, right? So you can see here, it's giving the answer based on the vector data. So there's a vector store which contains the information about the movie. And whenever I ask a question, the question is always answered based on the context. So what is the context? Your vector store data is used as the context. So whenever I make a request, the chain will automatically perform a similarity search, okay, for this question. So this question will be passed to the vector store and find the matching results, and that matching results will be used as the context, and the question will be the user question, and which is then rendered inside the prompt. So the search results will come here, user question will come here, and then that is passed to the LLM, and LLM response is printed by the output parser. So this is how we create a chain, and this is how we create a very simple RAG based application. So that's it from my side, because it's already 6:15. So I have just demonstrated a simple example of creating Langchain. I have showed you how the LLM can be used, that is the model can be used, then how we can use the prompt templates, then how we can use the output parsers, then how to create a simple chain by combining them. And then I have showed you how the vector store can be used. That is, FIAS I have used as an example. So the data is vectorized and stored inside the vector store. So I have used the Wikipedia page data to vectorize and store it. Then I have created a RAG chain combining the vector, prompt, LLM, and the output parser. So Thank you, everyone. So if you have any questions, please post your questions. I'll try to answer those questions. Like how you build a online business. So, Shubham, I couldn't understand the question. You have asked like how you build a right now one language translation one. So what do you mean? It's a connected question of something else. So Langchain is used to build AI solutions for the enterprise, right? Yeah. So yes, Shubham, the Langchain is used in enterprise applications for maybe summarize. Suppose in a health industry, we can use it for summarizing the patient's reports or generating the reports, financial report generation, okay, or uh, augmented data generations, test data generations. For that purposes, we can use the AI applications. But LangChain is specifically used for creating such APIs where you can put a question based on the custom data, maybe some virtual agents cases. So the virtual agent is supposed to answer your questions based on some custom data, like how I have uh, asked the questions about the movie, and it is answering all the questions based on the vector data which is there. Because to create organization specific virtual assistant, you can use the LangChain. Okay. So you can study materials. I think you have to, if you're looking for the LangChain, you are supposed to use the LangChain documentation only. I'll share the link for that. Can we use Excel or SQLDB? Yes, you can use that also as a data source. So you can get the data from the Excel or SQL and then store that data into a vector database. So here I have used a web page as a data source. You can use PDF as a data store. Oh, sorry, data source. You can use CSV as a data source, Excel as a data source. So from many places you can fetch the data and put into vector database. See, currently there is a question about what is the future of LangChain. So currently, you know that uh, AI is one of the most commonly used technology, and building AI applications using various frameworks. Like if you are using agentic AI applications, you can use LangChain, semantic kernel, AutoGen, agent chat. There are many frameworks available, and LangChain's benefit is it is a Python based, it is a community driven, and it is very simple to implement. Suppose if you want to create agents, or you can use tools, the tool calling feature of LangChain, so which we have not discussed because of the time constraint. But if you go through the documentation, you will see function calling or tool calling and creating agents using the LangChain. So like a co-pilot kind of Copilot, Chat GPT kind of agents you can create using LangChain also. So wherever you need a multi-agent workflow uh, kind of applications, where like co-pilots that do, you can also create similar applications using LangChain. But people also uses other frameworks. Like if you are using Microsoft uh, technologies, they can use the semantic kernel or autogen. They are also used for creating these AI applications. So there is no specific framework I can say like which is better. Depends. So if you like Python and open source and community driven one, Langchain is one of the best option. But if you are looking a Microsoft based uh, framework for building the AI applications like agentic applications, semantic kernel or autogens can be used. So whatever you do with that can be done here also. Maybe here and there some features which we easily implement here may not be easy in semantic kernel, but in some features of semantic kernel, which is very easy to implement here also like that. So I cannot say that which one is the best one. It depends. You see, this agent will replace backend API level. No, no, never. The agents are not going to replace the backend APIs. Backend APIs are always required for applications, and this agents are typically used to perform some operations, uh, automated operations. AI engineers or AI developers who build similar such applications. ML engineers are typically used, they are building the ML models. Sorry, I'm not talking anything. I'm just answering the questions in the chat itself.
Hello, sir. Should I end the session now? Should I end the meet? So, everyone, uh, you can end the session if you're done with your feedback. Yes, Saravana, do you mean you need the recording of this session?